Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. For this video I'll be discussing isotopes. But before we get and dive into isotopes, I want to give you guys a little bit of background information. Okay, you guys need to know these key 5 things up top here. Okay, starting off with the top 3, the first letter of each word comes out to pen. Make sure you understand that. Okay, protons, which is abbreviated as P, is a positively charged particle, carries a positive 1 charge. Electrons, negatively charged particle, carries a negative 1 charge. Electrons, symbol of E. Neutrons, they have no charge, symbol N. Make sure you understand those 3 for sure. It's very important. Okay, you can't continue in chemistry without knowing those key definitions. Okay, everything is based off this foundation. Next one, atomic number. Okay, atomic number is effectively the same thing as proton. It's the number of protons you have. Okay, so for example, carbon has 6 protons, so its Z is equal to 6. Fluorine has 9 protons, so effectively its Z is equal to 9. Nitrogen has 7 protons, its Z is equal to 7. Okay, it's the number of protons an atom has. Okay, the final thing before we get into isotopes is mass number, symbolized as A. Now it's kind of odd because you would expect atomic number to have the symbol A, but instead it doesn't. Mass number, for very odd reasons, or it's very strange, mass number has a symbol of A. Okay, so don't get these guys confused. People do that quite often. They get confused with atomic symbol and the mass number symbol. Okay, don't. Make sure you have them separate. So mass number is the sum of the protons and neutrons. Make sure you know this formula here. The number of protons plus the number of neutrons is equal to A, the mass number. Definite must. You need to know that. Okay, now before we get into isotopes and before we start using all this information and incorporate into isotopes, I want to talk about this little drawing I have on the right side of the board. Now what we have here is the very typical, it's a very generic but also very typical atomic structure of atoms for a given element. Okay, so for any given element, for any given atom, so for example for chlorine, bromine, iodine, cadmium, whatever it may be, you will always have in the center of that atom, in the very dead center, the nucleus, like we like to say in chemistry, is a very dense, positive, and a positively charged core. Okay, which is composed of protons. You also have neutrons there too, but you also have neutrons, so it's a composition of both protons and neutrons in this very core of an atom. That's the nucleus. Okay, so protons and neutrons. Well, for a second I want to ask you guys a question. What is the charge of the nucleus? Take a second to think about that question. Try to see if you come up with an answer. The charge of the nucleus will be positive, because if you have nothing but protons and neutrons, neutrons don't have any charge. Protons do have a charge. So in that case you will have nothing but a positive charge in the nucleus. Now surrounding that, orbiting the nucleus, you will have electrons, which is symbolized by these little dots here. Electrons, these are negatively charged particles. Okay, they surround the nucleus, orbit the nucleus. Okay, so this is the very typical, very generic atomic structure for any atom for a given element. Okay, granted, depending on the atom, the nucleus could be bigger or smaller, and the amount of electrons around the nucleus could be greater or smaller. Okay, so it depends on the element, it depends on the atom. Okay, but this is a very typical drawing of what an atom looks like. Okay, so before we move on to isotopes, I want to divert our attention to this periodic table I have for you guys. Okay, I'm gonna zoom in a little bit. Okay, now if you look at the periodic table, okay, I don't know if you guys can see it. Okay, I'll zoom in like that. You guys can see that. Up here we start off with hydrogen, and it starts off at 1. You go up to lithium, is hydrogen 1, then helium 2, then 3, 4, 5, 6, 7, 8, 9, 10. has this organization to it, the periodic table. And this organization we see with this increasing number is telling us, this number up top of each element is telling us the amount of protons we have in a given atom of that specific element. So for example, if you look at hydrogen, the number up top is a 1. So let me zoom in on hydrogen. Let's look at hydrogen right there. The number up top is 1. That tells us that hydrogen has 1 proton. Look at lithium. Lithium, it tells us that we have 3 protons. Beryllium, 4 protons. Magnesium, 12. Sodium, 11 protons. Very important, okay? Another information we can extrapolate from looking at the periodic table, let's look at this side over here. Okay, we can apply it to both sides of the periodic table. Is the amount of electrons, okay? In their elemental state, in their natural elemental state, oxygen, nitrogen, chlorine, every single element will have a neutral charge. That means it will have a balanced amount of protons and electrons. It will be neutral, okay? It won't have any specific positive or negative charge. It will be neutral. So if this top number tells us the amount of protons, so let's look at oxygen. If it tells us that oxygen has 8 protons, right? If oxygen has 8 protons, how many electrons must oxygen have in order for it to have a neutral charge in its elemental state? Well, it must be 8 as well, because if you have 8 positive things and 8 positive things and 8 negative things, they'll cancel out to a neutral charge, 0. Okay, same thing we could apply to nitrogen. We can determine the amount of electrons nitrogen has. Nitrogen has 7 protons. It must have 7 electrons in order for it to have a neutral charge in its elemental state. Same thing for carbon, okay? So that's another information you can extrapolate from the periodic table. Another thing you can look at, which ties more closely with isotopes, is the number below the element. So for example, nitrogen has 14.01, carbon has 12.01. What does that tell you? Well, that tells you the atomic weight of that specific element, okay? Now, keep in mind that every single element has different isotopes. So for example, for carbon has about 15 isotopes, but we'll look at 3. Carbon 12, carbon 13, carbon 14. All of them differ with respect to the amount, to the number of neutrons they have. The reason why carbon 12 is different from carbon 13 is because carbon 13 has 1 extra neutron. Carbon 14 has 1 extra neutron, okay? We'll talk a little bit more about that when we get to that board with the definition, okay? Now, this number below is the average mass, the average atomic weight of carbon, taking into consideration every single isotope of carbon. We get an average atomic weight. Now, the atomic weight is going to be closest to the isotope that is naturally most abundant. So in this case, carbon has an atomic weight of 12.01 because carbon 12 is naturally the most abundant in nature. Okay, something to think about. Okay, the reason why it's not close, the reason why this number is not closer to 13 is because we don't have as much carbon 13 in comparison to carbon 12. Same thing applies about carbon 14. We don't have as much carbon 14 in comparison to carbon 12. So you can extrapolate a lot of information from the periodic table. Okay, so let's get out of the periodic table and let's focus a little bit more on this definition here. What is an isotope? An isotope is an atom that has the same number of protons but different number of neutrons. Like I stated when we're looking at the periodic table, the reason why carbon 12 is different from carbon 13 is in respect to the number of neutrons carbon 13 has in comparison to carbon 12. Same thing applies to all of these isotopes. They have different number of neutrons. That's your bread and butter. You need to memorize that, internalize that any way you can. The reason why these guys are different is not in regards to protons, okay? The amount of protons one atom has for a given element is going to be the same across the board for different isotopes. The only reason why these guys are different is because of the number of neutrons. Again, protons tells you the identity of a element. So for example, if I were to tell you that what is the element that has a proton count of 25, so we look on the periodic table. Let me just bring it up here. We look at the periodic table, let's see 25. If you can see that right there, it's manganese, Mn, okay? So every isotope of manganese is going to have 25 protons. It's just that different isotopes of manganese will have different amount of neutrons. Again, protons tells you the identity of a given element. Oh, okay, that was long-winded. Okay, so let's look at how a professor could ask you a question in your class, and what other types of information you guys can find from isotopes. Okay, before I get into that, I want to just tell you a more basic generic way of understanding what an isotope is. An isotope is the different forms of an element. For example, you could find one isotope of carbon-12 forms graphite. Okay, another form of carbon, another isotope of carbon has another type of structure. Okay, it forms different types of structures. Okay, so also isotopes can be, if you guys want to know the significance of isotopes, it's involved in carbon dating. You can use isotopically labeled, radioactively labeled isotopes in medicine. Okay, so isotopes are very significant, and it's really important that you guys understand what it is. Okay, so make sure you guys understand all this. Make sure you know this definition, this formula, and make sure you know all these definitions. Again, this is key. This is foundation, and make sure you have an idea of the generic structure of a atom. Okay, so erase all this stuff here. Let's get into some more things that we can work out. Okay.